undergrad at the University of Massachusetts Amherst. I work with PhD candidate Kate Otter in Dr. Paul Katz's lab on campus. And today I'm going to be discussing narrowing down the behavioral basis for group feeding with the nudibranch mollusk Bergia stephaniae. So as we all know, there are many animals that engage in social feeding behavior, and here we have pictured just a few examples. Animals also use a variety of cues when aggregating around a food source. So pictured in the top left, we have a juvenile crab spider that uses the presence of conspecifics. Wolves communicate with one another through howling. Ants release pheromones at the bottoms of their feet that allow other ants to follow in their footsteps. And then the rosy wolf snail in the bottom right corner follows the slime trails of conspecifics and prey. Feeding in groups can also help animals consume more dangerous prey. So pictured here we have a group of wolves taking down a large caribou. There are of course benefits and drawbacks that come with group feeding. So some benefits include sustaining fewer injuries if you're feeding on dangerous prey. You can exert less energy, you can spend less time hunting, you're capable of finding more prey because there are more eyes and ears looking out for it. And then drawbacks include interacting with conspecifics. You may be more easily spotted by predators. You also have to compete for resources and prey with conspecifics. So I'm going to be discussing the nudibranch mollusk Bergia stephaniae and how it feeds on dangerous prey item Exoptasia diaphana, which is a type of sea anemone. And here on the left we have pictured the Bergia, and then on the right sea anemone that it feeds on. And this image on the right was actually a video originally, and what makes this anemone dangerous is it has nematocysts that can fire toxins and injure the Bergia, and then this Bergia in the center is actually being consumed by this anemone. So super dangerous. So just to give a brief outline of my talk, first big question I'm going to be going over is, do Bergia group up when feeding? And the second question is, what cues and mechanisms are they using to group feed? First big question, do Bergia use group feeding as a strategy to feed on dangerous prey? When we observe the Bergia feeding in the lab, we often see them form these large mobs or groups around a single anemone. So pictured on the left, we have 8 Bergia surrounding this one anemone, and then a few minutes later we now have 12 Bergia surrounding that same anemone. What we found when we feed them in the lab is that Bergia tend to cluster on one anemone in the tank when they're given 2 to feed on. So the image on the left shows 0 Bergia feeding on this one anemone, and then we have 10 Bergia feeding on the other anemone in the tank. And what this graph on the right is showing is the proportion of slugs that are found to feed on one anemone over another. So this 0.5 red line is if the Bergia are split evenly amongst the 2 anemones in the tank, and 1 is all the Bergia feeding on one of the anemones on the in the tank. So as you can see, there's a large proportion of Bergia that tend to feed on one anemone rather than splitting up evenly amongst the 2 in the tank. So what we did is we gave Bergia the option to feed alone on an anemone, and how we did this is we placed 8 anemones in a circle equidistant from the center, and we placed 8 Bergia in the center and allowed them to feed for 30 minutes. And here on the right is just a recording of the Bergia in the tank, and it has been sped up 30 times, so you can see a group of 4 Bergia feeding on one anemone at the bottom here. What we found was Bergia feed socially even when they're given the option to feed alone on an anemone. So our behavioral data shows the mean and max group sizes observed between 2 and 3 for mean group sizes and 2 and 4 for the max group sizes. When we compared our behavioral data to the simulated data, we found that Bergia do not choose independently of each other when feeding. So the simulated data is showing is expected mean and max group sizes to be between 1 and 2 and roughly 2. What our behavioral data is showing is larger mean and max group sizes, which means that Bergia aren't choosing to feed independently of each other when they're feeding in the tanks. What we then did is we hypothesized 3 mechanisms that Bergia could be using to form these groups when feeding. The first mechanism being injury, so Bergia are attracted to odorants being emitted from injured anemones. Second mechanism being slime trails, so Bergia are following the slime trails of conspecifics to an anemone. And then the third mechanism being pheromones, so Bergia are attracted to pheromones being emitted by conspecifics that are already feeding. So the first mechanism we tested was injury, so Bergia are attracted to the odorants being emitted from injured anemones. So mechanism 1, and how this was run is we gave the Bergia 2 alternative choice tests. So we had 2 anemones in opposite corners of the arena, and one had previously been eaten by a conspecific. And then we placed the Bergia in the center, and once it came in contact with one of the 2 anemones in the tank, trial ended. And what we found is the Bergia preferred the odor of an intact anemone over one that had been previously eaten on by a conspecific, which is the opposite of what we had expected. We expected there to be a preference for the injured anemone over that of the intact anemone. And all these Bergia were food deprived for 7 days. They were also food deprived for 7 days in the circular configuration, which I forgot to mention, but they preferred the odor of an intact anemone over that had been injured. So just to go over those results real quick, there was a preference for intact anemones for mechanism 1, which was injury. We then tested mechanism 2, which was Bergia were following the slime trails of conspecifics. So this again was a 2 alternative choice test with 2 anemones being placed in opposite corners of the arena. This time we allowed a helper slug to create a slime trail to one of the anemones in the tank. Once it came in contact with that anemone, it was removed, and the focal slug was then placed in the center of the tank. Again, once that came in contact with one of the anemones in the tank, the trial ended. And what we found is Bergia don't follow slime trails, so they were just as likely to come in contact with the intact anemone as they were with the anemone that had a slime trail leading up to it. So just to again go over those results real quick, mechanism 1, we hypothesized that Bergia were attracted to odorants being emitted from injured anemones. What we found was there was a preference for intact anemones. Mechanism 2 in slime trails, which was again run with the 7 days food deprived Bergia, we found that there was no preference. And then now we'll be testing mechanism 3, pheromones. So Bergia preferred the anemone with the conspecific already feeding on it. Again, a 2 alternative choice test was run with 7 days food deprived Bergia, and this time a conspecific was allowed to begin feeding on one of the anemones in a separate tank, and then once it was feeding, it was placed in the main arena opposite from that of an intact anemone. The focal slug was then allowed to come placed in the tank and allowed to come into contact with one of the 2 anemones. Trial ended, and what we found is Bergia weren't more attracted to the scent of an anemone with the conspecific feeding on it. And this graph on the right just shows our results. This may seem like a significant difference amongst intact anemones and feeding conspecifics, but it wasn't significant enough, and there wasn't a large enough difference between the two to be considered significant. But what it does show is that even if it were significant, the Bergia would be more attracted to an intact anemone over that of a feeding conspecific, but it wasn't significant enough or a big enough difference for us to actually say that they preferred the intact anemone over that of a feeding conspecific. So just a quick summary of our results. For mechanism 1, there was a preference for intact anemone over that had been previously injured by a conspecific. And then for mechanism 2, there was no preference for an anemone with a slime trail. And then for mechanism 3, there was no preference for an anemone with the conspecific already feeding on it, so Bergia were more attracted to an anemone with a conspecific. We then hypothesized that Bergia could be using a combination of cues, so we decided to test slime trails with pheromones. This was again a 2 alternative choice test on 7 days food deprived Bergia. This time the helper slug was allowed to make the slime trail to the anemone and begin feeding on it. Then the focal slug was placed in the tank, and once it came in contact with one of the 2 anemones, the trial ended. Again, we found no preference. They weren't more likely to be found to come in contact with the intact anemone over that with a slime trail and a feeding conspecific. Just to summarize our findings, Bergia do feed in groups when given the option to feed alone. What we still don't know is which cues they're using to form those groups. We did decide to test individual differences to see if there may be individual differences amongst the Bergia that could result in them preferring to feed in groups or alone, but I'm currently combing through that data. So I'd just like to thank the CATS lab, Professor Paul Katz, Kate Otter, all the other amazing people in the lab, UMass Amherst, Brain Initiative Project, LESIP, and then the UMass Stats consultants. Thank you.